The last Tuesday. What the final day of the dinosaurs reveals about our own fragility. Here's something that will mess with your head. Right now, at this exact moment, you're living inside an illusion. Not some philosophical metaphor. An actual cognitive trick your brain plays on you every single day. It's the illusion that tomorrow will come, that next week will arrive, that the pattern of your life, the rhythm of your world, the continuity of everything you know will just keep going. And here's the thing that should terrify you and fascinate you in equal measure. For 165 million years, the dinosaurs believed that too. They had every reason to. Their world had been stable longer than our minds can truly comprehend. And then one Tuesday morning, 66 million years ago, everything changed in less time than it takes you to blink. What happened next wasn't just the end of the dinosaurs. It was a masterclass in how quickly certainty becomes chaos, how continuity shatters, and why understanding that single day might be the most important thing you learn about your own survival. Because here's what nobody talks about. We're living in a pre-asteroid world right now, and we don't even realize it. Let's talk about what 165 million years actually means, because your brain isn't equipped to process that kind of time. Modern humans, Homo sapiens, have existed for roughly 300,000 years. That seems like forever, right? It's not. It's not even close. The dinosaurs ruled this planet for a span of time that is 550 times longer than we've been around. Think about that. If you compress the entire reign of the dinosaurs into a single year, all of human history would be the last 13 hours of December 31st. But here's what's important to understand about those 165 million years. They weren't some brief golden age. This wasn't a flash in the pan. Generation after generation after generation of dinosaurs lived and died never knowing anything but stability. The climate was consistent. The food was abundant. Sure, species evolved, some died out naturally, new ones emerged, but the system itself, the fundamental pattern of life on Earth, remained intact. Dinosaurs weren't just successful. They were so successful that their dominance seemed like a law of nature. Imagine being a Tyrannosaurus rex 66 million years ago. Your species has been around for about 2 million years at this point. Your ancestors before you stretched back through time so far that if you could somehow comprehend it, you'd see an unbroken chain of predators, of dominance, of continuity that would make your own existence feel inevitable, permanent. The idea that it could all end, that the entire structure of life on Earth could collapse, would seem absurd. That's not pessimism or optimism, that's just impossible. The world has always been this way. The world will always be this way. And this is where we need to stop and recognize something uncomfortable. You feel the same way right now. You wake up every morning with the implicit assumption that the fundamental structure of your world will hold. The sun will rise. The grocery stores will have food. The power grid will function. Society will continue operating according to the rules you understand. And listen, I'm not saying you're wrong to assume that. Statistically, you're probably right. Tomorrow will probably look a lot like today. But the dinosaurs were statistically right too, for 165 million years. Until they weren't. The crucial insight here is understanding what stability actually creates in complex systems. It creates vulnerability. Not despite the stability, but because of it. When a system remains unchanged for long enough, everything within that system becomes optimized for those exact conditions. Dinosaurs weren't just adapted to their environment, they were exquisitely, perfectly adapted to it. Large body sizes worked because food was abundant. Cold-bloodedness worked because the climate was warm. Specialization worked because ecological niches remained stable. Every single feature that made dinosaurs successful was also a feature that made them fragile, because they were all betting on continuity. This is what researchers call the stability paradox, and it shows up everywhere once you start looking for it. Empires that dominate for centuries become unable to imagine their own collapse, which makes them vulnerable to exactly that collapse. Species that thrive in stable environments lose the genetic diversity needed to survive change. Even your own life operates on this principle. The more your daily routine works, the more dependent you become on the specific conditions that make it work, and the more devastating any disruption becomes. So when we talk about the last day of the dinosaurs, we're not just talking about a space rock hitting a planet. We're talking about the moment when the longest continuous success story in the history of complex life on Earth discovered that continuity itself was the illusion. Now let's rewind a few weeks before impact and talk about something that keeps me up at night. There was a moment, probably several weeks before that asteroid hit Earth, when it became visible in the night sky. Not to telescopes, because obviously dinosaurs didn't have telescopes, but to the naked eye. Just a small dot of light that shouldn't be there. A new star in a sky that hadn't changed in millions of years. And here's what haunts me about that. If there had been any dinosaur with the cognitive capacity to recognize what they were seeing, to understand that this small dot of light was an object moving toward them through space growing larger every night, there would have been absolutely nothing they could do about it. Zero. They could watch their own extinction approaching night after night, bright and beautiful and utterly inevitable. This is worth sitting with for a moment because it reveals something profound about awareness and power. We often assume that knowing about a threat gives us control over it. That's why we build early warning systems, why we track hurricanes, why we monitor earthquake faults. The logic is simple. See it coming, prepare for it, survive it. But that logic only works if the scale of the threat matches the scale of your capability to respond. And sometimes, not often, but sometimes, the universe presents you with a threat so large that awareness without capability is just torture. The asteroid that killed the dinosaurs was approximately 10 kilometers across. For reference, that's larger than Mount Everest. Imagine Mount Everest moving through space at 20 kilometers per second, which is roughly 60 times the speed of sound. The kinetic energy contained in that much mass moving at that speed is almost incomprehensible. We measure it in billions of nuclear weapons, but even that doesn't really capture it because nuclear weapons release energy through chain reactions over time. This was instantaneous. Every joule of energy, all at once, in a single point of contact. But before we get to the impact, let's think about those final weeks. As the asteroid moved closer to Earth, it would have appeared brighter each night. Any creature capable of pattern recognition would have noticed. The sky was changing. Something was different. And this is where we stumble into one of the strange psychological realities of catastrophe. Slow-motion apocalypses are almost harder to process than sudden ones. Think about how you react to threats in your own life. Immediate dangers trigger instant responses. Someone swings at you, you dodge, you smell smoke, you run. But threats that unfold over days or weeks or months, those are the ones that paralyze us. Because every day that passes without catastrophe becomes evidence that catastrophe won't come. This is called normalcy bias, and it's one of the most dangerous cognitive traps humans and probably many other species face. Normalcy bias is why people ignore evacuation orders during hurricanes. It's why societies collapse slowly and then all at once. It's why you keep hitting snooze even though you know you're going to be late. And here's the really disturbing part. Normalcy bias isn't irrational. Most of the time, it's exactly right. Most threats don't materialize. Most warnings are false alarms. The sky doesn't actually fall. So your brain, being the prediction machine that it is, learns to discount unlikely scenarios in favor of likely ones. And the likeliest scenario, almost always, is that tomorrow will resemble today. Until that one day when it doesn't. The dinosaurs who might have noticed that strange new object in the sky had no framework for understanding it. No mythology of falling stars destroying worlds, no scientific models of asteroid impacts, no cultural memory of extinction events. Just a bright thing in the sky getting brighter, and every instinct they had telling them to continue eating, sleeping, mating, surviving exactly as they always had. The pattern continuing right up until the moment it shattered completely. Let's talk about the actual impact, but not in the way you've heard it before. Not as a disaster movie sequence of explosions and destruction. Instead, let's talk about what happens when you fundamentally break the rules of physics as they apply to matter in everyday experience. The asteroid hit the shallow ocean near what is now the Yucatan Peninsula in Mexico. The moment of contact, and I mean the literal instant when the leading edge of the asteroid touched the surface of the water, that moment was the last moment the Earth existed in its previous state. Because here's what happens when an object moving at 20 kilometers per second hits something. Normal material properties cease to apply. Rock doesn't act like rock anymore. Water doesn't act like water. At those velocities and pressures, solid bedrock flows like liquid. Liquid water vaporizes into plasma. The asteroid itself doesn't crumble or shatter the way you'd imagine. It vaporizes. All 10 kilometers of mountain-sized rock converted to gas and plasma in a fraction of a second, releasing energy equivalent to 10 billion Hiroshima bombs. But here's what your brain can't quite grasp about that energy release. It's not just heat and light spreading out from a central point. The impact was so violent that it temporarily created a hole in the Earth's crust 25 kilometers deep. That's deeper than the crust is thick in most places. The impact literally punched through the outer layer of the planet. The ocean, thousands of kilometers of water, was pushed back. Not splashed, pushed, moved out of the way by pure force, creating a temporary empty space where an ocean had been seconds before. And then the crust bounced back, because that's what happens when you hit something that hard. You don't just destroy it, you make it ring like a bell. The bedrock, melted and flowing from the impact, rebounded upward and formed a temporary mountain 10 kilometers high at the center of the crater. A mountain of molten rock stretching into the sky, existing for maybe a few minutes before collapsing back down. If you could have watched this from space, which obviously you couldn't have survived to do, you would have seen the Earth's surface behave like the surface of a pond after a stone is dropped in. Ripples of solid rock rolling outward from the impact site. Now let's talk about what this meant for anything alive within a few thousand kilometers. The thermal radiation from the impact flash traveled at the speed of light, which means it arrived before the sound, before the shock wave, before the earthquake. Just instant, searing heat. Everything within about 1,500 kilometers was burned immediately. Not caught in fires, not gradually heated up. Just instantly exposed to temperatures hot enough to vaporize organic matter. If you were a dinosaur in Texas, or the Caribbean or Central America when this happened, you didn't experience the impact. You just stopped existing, converted from living creature to carbon residue in less time than it takes a neuron to fire. But most dinosaurs weren't in that immediate kill zone. Most of them were far enough away that they had a few minutes, maybe an hour, maybe several hours before the destruction reached them. And this is where things get psychologically interesting, because we need to imagine what it was like to experience this catastrophe without understanding what was happening. The first thing you'd notice anywhere on Earth would be the earthquake. Not a normal earthquake. A magnitude 11 earthquake, which is off the scale of anything we've ever recorded. The ground moving in ways ground doesn't move. Not shaking, undulating. Waves of solid earth rolling like ocean swells. Trees not just falling but being tossed into the air. Mountains crumbling. And everywhere, the sound. Not the sound of the impact itself, that would come later. The sound of everything breaking at once. For dinosaurs in North America, the shock wave from the blast would have arrived moving faster than the speed of sound, which creates a strange effect. The destruction would arrive before the warning. You'd see the forest in front of you explode into splinters, and only then would you hear the roar of what caused it. The atmosphere itself becoming a weapon, moving so fast and with so much force that it scoured landscapes clean. Soil, vegetation, animals, all of it shredded and thrown thousands of kilometers away. And then the oceans returned. The water that had been pushed back by the impact, thousands of cubic kilometers of it, collapsed back into the crater and was launched outward as a ring of tsunamis. Not one tsunami, multiple tsunamis, radiating out in all directions, some of them over a kilometer tall enough to cover any skyscraper humans would ever build. These waves destroyed coastlines on multiple continents. 15 hours after impact, waves reaching South America after traveling all the way around the planet were still 100 meters high. But here's what we need to understand about all of this destruction. It was still just the beginning. The immediate effects of the impact, catastrophic as they were, probably killed a relatively small percentage of dinosaurs. Most of them lived inland, away from the coasts. Most of them were far enough from the impact that they survived the heat flash and the shockwave. The real extinction event hadn't even started yet. Now we get to the part that really disturbs me, and it should disturb you too. Because this is where the impact stops being a localized disaster and becomes a global extinction event. This is about the debris. When the asteroid vaporized and the Earth's crust was blasted into the air, an enormous amount of material was ejected into space. We're talking about millions of tons of rock, some of it in pieces the size of boulders, some of it melted into tiny droplets, all of it thrown upward with enough velocity to leave Earth's atmosphere entirely. Some of that material went into orbit. Some of it escaped Earth's gravity well completely and is probably still out there somewhere in the solar system. But most of it fell back down. And here's where the physics gets nightmarish. When objects enter the atmosphere at high speed, friction with air molecules heats them up. That's why meteors glow. That's why spacecraft need heat shields. Usually this happens to relatively small objects, and the heat dissipates into the atmosphere without much effect. But this wasn't a few small objects. This was millions of tons of material, some of it moving at speeds fast enough to have been launched into space in the first place, all of it falling back through the atmosphere over the course of hours. The atmospheric heating wasn't localized. It was global. As the Earth rotated beneath this falling debris field, every part of the planet was exposed, and the heat was intense. We don't know exactly how hot it got, and there's genuine scientific debate about this, but the estimates range from hundreds of degrees Celsius for several minutes to thousands of degrees for about a minute. Either way, the air became an oven. Imagine you're a dinosaur who survived the immediate impact. Maybe you're in what is now Montana or China or Africa. The earthquake was terrifying, but you survived it. You're confused, frightened, but you're alive. And then the sky starts to glow. Not like sunrise, like a furnace. The air temperature rises rapidly. 10 degrees, 20, 50, 100. And there's nowhere to go. You can't outrun hot air. It's everywhere at once. The only creatures that survived this heat pulse were ones that could burrow underground or shelter in caves or underwater. Anything exposed on the surface was cooked. Not burned in fires, not yet. Just exposed to air hot enough to kill. Birds in flight fell from the sky. Dinosaurs in open plains died where they stood. The global population of large animals dropped by some massive percentage in the span of less than an hour. And then the fires started. The combination of superheated air and falling debris ignited organic material on the ground. Forest floors, dried vegetation, anything that could burn began to burn. And because this was happening everywhere at once, the fires weren't isolated. They were continental. Massive firestorms raged across every landmass on Earth. Some of these fires probably burned for months. Now think about what this means for the biosphere. It's not just the direct damage from the fires, it's what fires produce: smoke, ash, particulate matter. All of that being pumped into the atmosphere, adding to the debris already there, creating a layer of material between the surface and the sun. The sky began to darken, but we're still not done with that day. Because while the fires were spreading and the air was cooling from its heat pulse, something else was happening. The massive plume of vaporized material from the impact site had reached the upper atmosphere and was spreading around the globe. This wasn't just dust. This was vaporized bedrock, sulfur aerosols, and eventually the smoke from the burning planet, all combining to create a blanket around the Earth. Within days, the planet was dark. Not nighttime dark, darker. The kind of dark where photosynthesis becomes impossible. And without photosynthesis, the entire food chain collapses from the bottom up. Plants die, herbivores starve, carnivores starve. The few survivors of the heat pulse and the fires now found themselves in a world without food, without light, and rapidly getting colder. This is called an impact winter, and it's in many ways more devastating than the impact itself. Because the impact killed quickly. Impact winter killed slowly. Over weeks and months, temperatures dropped as much as 25 degrees Celsius globally. The oceans were hit especially hard because the lack of sunlight killed plankton, the base of the marine food chain. Over 90% of plankton species went extinct, which meant everything that ate plankton starved, which meant everything that ate plankton eaters starved, cascading all the way up to the massive marine reptiles that had dominated the oceans for millions of years. On land, the situation was equally grim. The only organisms that thrived were fungi, which don't need sunlight and which suddenly had unlimited dead organic matter to feed on. Some researchers suggest there was a brief period called the fungal spike, where fungi temporarily became the dominant life form on Earth's surface, covering the dead world in a carpet of decomposition. The impact winter lasted for decades, multiple decades of cold, dark, toxic conditions. Most large animals couldn't survive it. Most plant species couldn't survive it. 75% of all species on Earth went extinct. Not just dinosaurs, 75% of everything. The mammals that would eventually evolve into us only survived because they were small enough to live in burrows, generalized enough to eat a variety of foods, and lucky enough to be in the right places. Let's talk about what Earth looked like when the dust finally settled, literally and figuratively. Because this is where we see something remarkable about life, something that's both inspiring and unsettling. The survivors emerged into an alien world. If you could somehow transport yourself to Earth 65 million years ago, a few years after the impact, you wouldn't recognize it as the same planet. The lush forests were gone, replaced by dead gray landscapes covered in ash. The skies were still hazy, the oceans were depleted and acidic, the food chains were broken, and yet life persisted. The survivors weren't the strongest or the most specialized. They were the most adaptable. Small mammals that could eat almost anything, could shelter in burrows, could survive on very little. Birds, which were actually small feathered dinosaurs that could fly away from danger and exploit different ecological niches. Reptiles like crocodiles and turtles that could go months without food. Plants that could regrow from root systems after their surface structures burned. What happened next took millions of years. The empty ecological niches left by the extinct species became opportunities for the survivors. Mammals, which had spent over 100 million years being small, nocturnal, and insignificant, suddenly had room to evolve. Without large dinosaurs eating all the vegetation, without large predators hunting them, mammals could experiment with new body sizes, new behaviors, new ecological roles. This is adaptive radiation, one of the most important concepts in evolutionary biology. When a mass extinction clears out established species, the survivors rapidly diversify to fill the empty spaces. And this is exactly what happened with mammals. Within 10 million years, which is incredibly fast in evolutionary terms, mammals had evolved into forms ranging from tiny shrews to elephant-sized herbivores. They'd spread across every continent and occupied every habitat. They became the dominant terrestrial animals on Earth, a position they still hold today. And here's the profound part. Without the asteroid impact, this never would have happened. Mammals existed alongside dinosaurs for over 100 million years and never became dominant because dinosaurs were too successful. They occupied all the ecological niches that large animals could occupy. There was no room for mammals to grow, to diversify, to experiment. The only reason we exist, the only reason primates evolved, the only reason you're listening to this right now, is because an asteroid destroyed the continuity of life 66 million years ago and created space for something new. This should challenge how you think about catastrophe. We tend to view disasters as purely negative, as interruptions to progress, as setbacks. And from the perspective of the dinosaurs, the asteroid impact was absolutely catastrophic. It ended their world. But from a broader perspective, that catastrophe was also an opportunity. It reset the evolutionary playing field and allowed new forms of life to emerge and thrive. Now, before anyone misunderstands me, I'm not saying catastrophes are good. I'm not suggesting we should welcome extinction events. What I am saying is that complex systems, whether they're ecosystems or civilizations or economies, sometimes become locked into stable patterns that prevent new possibilities from emerging. And sometimes it takes a massive disruption to break those patterns and allow innovation to occur. The question this raises, and it's an uncomfortable question, is whether our current global civilization is locked into patterns that need to be disrupted. Are we in our own Cretaceous period, assuming continuity while the system becomes increasingly fragile? And if so, what kind of disruption would it take to create space for something new? Now we need to talk about us. Because there's a reason I've spent 20+ minutes telling you about dinosaurs. And it's not just because their extinction is fascinating. It's because we are living in a remarkably similar situation, and most of us don't see it. Modern humans have existed for approximately 300,000 years. In that time, we've gone from small bands of hunter-gatherers to a globally connected civilization of 8 billion people. We've built cities, developed agriculture, created art and music and literature, split the atom, landed on the moon, and mapped our own genome. By any objective measure, we are the most successful large animal currently alive on Earth. But here's what should make you pause. We've been around for 0.1% of the time dinosaurs existed. That's not a typo. If the dinosaurs' reign was a 100-hour movie, we've been here for 6 minutes. And in those 6 minutes, we've achieved things that seem to prove we're fundamentally different from every other species that's ever lived. We're conscious. We're technological. We can predict threats and take action to prevent them. We're not at the mercy of blind natural forces like the dinosaurs were, except we absolutely are. We just don't like to admit it. Let's start with asteroids, since that's what killed the dinosaurs. We are currently tracking about 30,000 near-Earth objects, which is a good start. We've even successfully tested a planetary defense system by deliberately crashing a spacecraft into an asteroid to change its trajectory. This is genuinely impressive and suggests that, unlike the dinosaurs, we could potentially deflect an incoming asteroid if we detected it early enough. But notice all the qualifiers in that statement. Could potentially. If we detected it early enough. The truth is that our asteroid detection systems are far from complete. We've probably found most of the really big ones, the civilization enders, but there are thousands of smaller asteroids, still large enough to cause regional catastrophes, that we haven't identified yet. And even for the ones we have identified, our ability to actually deflect them is largely theoretical and would require years of preparation time. So yes, we're better positioned than the dinosaurs were. But we're not invulnerable. An asteroid could end our civilization, and there's nothing particularly implausible about that scenario. It's just unlikely on human timescales. But unlikely is not the same as impossible, and the dinosaurs could tell you that if they were still around. But asteroids are actually the least of our concerns, because at least asteroids are random external threats. The bigger danger is what we're doing to ourselves. Climate change, nuclear weapons, engineered pandemics, artificial intelligence. These are all threats that we created, that we're actively making worse, and that we theoretically have the power to prevent but somehow aren't preventing. This is the human paradox. We're smart enough to see the threats coming, but not wise enough to actually do anything about them. We're trapped by the same illusion of continuity that trapped the dinosaurs. We know intellectually that our current way of life could end, but we don't feel it. We don't act like it. We continue optimizing for the short term, for quarterly profits, for the next election cycle, for our own immediate comfort. Because the alternative, actually changing how we live at a fundamental level, seems too difficult, too expensive, too disruptive. And here's the really insidious part. The longer things remain stable, the more resistant to change we become. Every year that passes without catastrophe reinforces the belief that catastrophe won't come. Every technological advance makes us feel more invulnerable. Every problem we solve makes us think we can solve all problems. We're becoming like the late Cretaceous dinosaurs, perfectly adapted to our current conditions, and therefore increasingly vulnerable to any change in those conditions. The difference, and it's a crucial difference, is that we have the capacity for foresight. We can imagine futures that haven't happened yet. We can run models and simulations. We can learn from the past, including from extinctions that happened millions of years before we existed. The question is whether we'll actually use that capacity, or whether we'll continue sleepwalking toward our own asteroid moment, whatever form that takes. So let's bring this full circle and talk about what the extinction of the dinosaurs actually teaches us about living in an uncertain world. Because I think the lesson is more nuanced than just be prepared for disaster. The dinosaurs were not failures. This is important to understand. They were incredibly successful for an almost incomprehensible period of time. They adapted, they evolved, they survived multiple smaller extinction events. They were the dominant form of life on Earth for longer than almost any other group of large animals. And they didn't die out because they were weak or stupid or poorly adapted. They died because something happened that was so far outside the normal parameters of existence that no amount of adaptation could save them. This is humbling. It means that success, even spectacular success sustained over millions of years, is not a guarantee of survival. It means that the universe doesn't care how well adapted you are if it throws something at you that's outside the range of what you adapted to. It means that on a long enough timescale, improbable events become inevitable, and when they happen, most of what existed before simply ceases to exist. But here's the thing. The dinosaurs didn't all die. Their lineage continues in birds. Every sparrow and pigeon and eagle you see is a living dinosaur, a descendant of the creatures that survived the Cretaceous extinction. And that's worth thinking about. The survivors weren't necessarily better or stronger than the ones who died. They were luckier. They happened to be the right size, in the right place, with the right set of characteristics to endure conditions that killed everything else. So what does this mean for us? First, it means accepting that continuity is fragile, always, regardless of how permanent it seems. The world as you know it could end tomorrow, or it could continue for thousands of years, and there's no way to know which. That's not pessimism, it's just reality. Second, it means that preparation and resilience are not about preventing catastrophe, because some catastrophes can't be prevented. They're about increasing the chances that something survives on the other side. This is where I think a lot of disaster preparedness thinking goes wrong. We focus on maintaining the current system, on preventing change, on keeping things exactly as they are. But the dinosaur extinction shows us that sometimes the system itself can't be maintained. Sometimes the best you can do is make sure that whatever comes next has a chance to survive and rebuild. That might mean distributed systems instead of centralized ones. Diversity instead of optimization. Flexibility instead of efficiency. It might mean accepting that the world our children inherit won't look like our world, and preparing them for that reality rather than pretending continuity is guaranteed. And finally, it means recognizing that we are not special. We are not exempt from the forces that ended the dinosaurs. We're smarter. Yes. We're more technologically advanced. Absolutely. But we're still biological creatures living on a planet that orbits a star in a universe that is fundamentally indifferent to our existence. We can tilt the odds in our favor. We can see some threats coming and take action. But we can't eliminate uncertainty. We can't make ourselves invulnerable. The asteroid that killed the dinosaurs appeared in the sky weeks before it hit. If there had been any creature capable of understanding what they were seeing, they could have watched their doom approaching night after night, beautiful and terrible and unstoppable. We have the advantage of that understanding now. We can see our potential dooms, some of them approaching slowly, some waiting in the wings, all of them possible. The question is what we do with that knowledge. Do we use it to build resilience, to create systems that can survive disruption, to prepare for a future that might be radically different from our present? Or do we continue living as if continuity is guaranteed, optimizing for a stable present while ignoring the fragility underneath? Because here's what the dinosaurs teach us. The illusion of continuity is seductive and powerful and dangerous. It makes you think tomorrow will be like today. It makes you think the pattern will hold, until one Tuesday morning when it doesn't. The dinosaurs couldn't have known what was coming. We can. What we do with that knowledge, whether we use it to build something that lasts, or whether we simply hope we get lucky, that's the choice that defines whether we're any wiser than the creatures whose bones we dig up and whose extinction we study. The continuity you feel right now, the stability of your world, the assumption that things will keep going as they have been, that's not a guarantee. It's a gift. The question is whether you'll treat it as one. And maybe that's the real lesson from 66 million years ago. Not that catastrophe is coming, although it might be. Not that we should live in fear, because that's no way to live. But that we should hold our certainties lightly, build with resilience in mind, and remember that every moment of continuity is borrowed time. The dinosaurs had 165 million years. We've had 300,000 and we're not even sure we'll make it to 400,000. The difference is that they didn't know their time was limited. We do. Let's hope that makes a difference.